Strategy to convert the number 110 to its 8-bit binary equivalent. So always a good idea to start with the place order grid so that you don't lose track of where the ones and zeros go. So to do this, you want to draw the grid. Just start on the right hand side with the smallest number and put in the power at the moment until you get used to it. So start with 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6 and 2 to the power 7. Now the reason I'm stopping at 2 to the power 7 is because I was told in the question it's an 8-bit binary equivalent, and we've used 1, 2, 3, 4, 5, 6, 7, 8 columns, 8 placeholders we're going to have here. I'm just putting in these lines to help us know which column we have to put the 1 in to construct this or convert this number. So I always, I think I might change the colour of my pen here, I always put in the decimal equivalent of this because I find it a lot easier. So 2 to the power 0 is actually the 1's column, 2 to the power 1 is the 2's column, 2 to the power 2 is the 4, that's 2 times 2 which is 4, 2 times 2 times 2 is 8, and so on, 16, 32, 64 and 128. Now if you are not sure how I've managed to get these numbers, then just think about it for a minute. If we take this 2 to the power 7, that is the same as saying 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. One more. So 7 of those. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. So this is how this is working. Right, so now that we've identified that, the next thing to do is do your workout, do your working. So we're starting, our number we're converting is 110, so write that down here at the side, and then ask yourself, in the largest placeholder, does it go into 110? 120 is too big, we can't use it, so I'm going to put a 0 in this column, and I'm going to subtract, I'm not going to subtract anything because I haven't used anything. Then I'm going to move to the next column, which is 64. 64 is less than 110, so it can go into it. So I'm going to use that. So I put a 1 there, subtract 64 from 110, and I'm left with a number, which I'll work out as 1 to the top here, 1 to the bottom, so that's 6. And I need to move that over there to become 11, so that's 7 from 11, which is 4. 46. So that's your 10, yeah. Right, so I've got 46 left. Does 32 go into 46? Yes, it does. So we're going to use that 32. So we want to subtract 32 now from 46. So that's an easier one to do. That's a 4 and a 1. So I've got 14 left. 16 is too big, it does not go into 14, so it gets a 0. 8 can go into 14, so we use that, and we're left with 6. So that was minus 8, and we're left with 6. 4 does go into 6, so we'll use the 4. Subtract the 4, so minus 4, and we're left with 2. So we'll use that 2, we've got nothing left. So the last place is a 0. Now, we knew this last place would be a 0 because our number is even. It's only if it's an odd number that you would have a 1. So at the moment, this is potentially the binary equivalent of the decimal 110, we have to check it. Always check your working to see if you're correct. So I'm going to change my pen colour. Right, so 64, we've used a 64, we've used 32, we've used 8, we've used 4, and we've used 2. And all we need to do is add these up to see if we're correct. So 2 and 4 is 6, 14, 16 and 20, so we put a 0 there, carry the 2. 2 and 3 is 5, 5 and 6 is 11. So we end up back at the beginning with our 110. So we have checked this. So we can say with confidence now that 0, 1, 1, 0, 1, 1, 1, 0 base 2 is the equivalent of 110 base 10. These questions always come up in your exam. This is the way I suggest you do that in your exam when you're stressed out. Just write it down.